Hi, here is another application of differentiation. So this one is on connected rate of change. So it says the radius of a circle shadow or circular shadow is increasing at a constant rate of 2 centimeters per second. Find the rate at which the area is increasing when the radius is 18 centimeters. Express your answer in terms of pi. So we already know that when we speak of rate of change, we are going to use derivatives, or this is an application of derivatives. And a more complex um, concept of rate of change is what we call the connected rate of change. It is called connected rate of change because you have two or more rate of change or two or more variables changing at the same time. So for example, in this problem it says the radius of a circular shadow is increasing. So there is a circular shadow, and with respect to time, so this is increasing. Okay, so maybe an object is at the sky and is falling down, and on the ground you will see that the shadow is increasing as the object approaches the ground. So the shadow is increasing at a constant rate of 2 centimeters per second. So note that this rate is measured in terms of the shadow, the, the area of the shadow, or rather the length of the radius with respect to time, because this is 2 centimeters per second. So the rate of change with respect to time, the rate of change of the radius with respect to time, can be written as dr over dt. So this is the rate of change of the radius with respect to time. Okay, now what we want to find is the rate at which the area is increasing when the radius is 18. So the rate of change of area with respect to time can be written as dA, derivative of A, with respect to time. So this is the rate of change of the area with respect to time on a particular area, in this case a circular area. So that alone gives us the idea on what function that we can use. So since this is a circle, then we can use the formula for the area of a circle. If this is a different figure, then you have to use a different formula. If that's a rectangle, then you have to use length times width. If that's a square, then you have to use the side squared. But since the shadow is a circular shadow, then the function should be in terms of the area of the circle, which is pi r squared. So how do we connect this dr over dt and dA over dt? So as you can see, this tells us that we need to differentiate the area. But the thing is, you have to differentiate the area with respect to time. Take note, differentiating with respect to time is different to differentiating area with respect to the radius. If I will get the area, or the derivative of the area with respect to the radius, the dA over dr, this is simply 2 pi r by the rule on differentiation. So dA over dr is 2 pi r. But that's not what we want. What we want is dA over dt. Now, the trick here is to use the concept of the chain rule. dA over dt is actually equivalent to dA over dt times, or dr rather, this is dr, dA over dr times dr over dt. Okay, so we need to split dA over dt into this expression, dA over dr times dr over dt. If we do this, then we will be able to find dA over dt. Now, let's focus our attention on the new expression. So dA over dr, that is basically the derivative of the area with respect to r, which is equal to 2 pi r. Now, dr over dt is the rate of change of the radius with respect to time, which is actually given in the problem. It says the radius of a circular shadow is increasing at a constant rate of 2. So dr over dt is basically 2. Okay? So since what we want to find is the rate of the area when the radius is 18, then dA over dt when r is equal to 18 will be 2 pi times 18 times the extra 2. And then all we have to do is to find the value of this number. So 2 pi times 18, that's 36 times 2. 36 times 2 is 72, so this is 72 pi. So the rate of change in the area with respect to time at the time when the radius is equal to 18 is 72 pi. So this is in area, so you have square centimeters per second. Okay, so let's recap what we have done here. So this is an application of differentiation. It's called the connected rate of change. So the key idea is to identify what function should be used in this problem, and then identify the known rates and the rate that you want to find. So the known rate is dr over dt, that is the change in the radius with respect to time, and is given by 2 centimeters per second. What we want to find is the rate of area at the time when the radius is 18 centimeters. So this is what we want to find. Now the trick that we did here using the chain rule is that we should know that dA over dt is equivalent to dA over dr. So this is dr times dr over dt. And once we do that, we can find the dA over dr, which will come from a equals pi r squared. Just differentiate with respect to r. Use the rule, so dA over dr is 2 pi r. So dA over dr is 2 pi r, and dr over dt has a value equal to 2. And then just put the numbers, simplify the numbers, and then you will get the rate of change of the area with respect to time at the time when the radius is equal to 18. Okay, so that's it.